This is Hydrology 2018. I'm going to show you some watersheds, some stormwater networks, culverts, some of that type of stuff today. And I'll get started here in a minute or two. We'll give folks a chance to come in. But we'll start off here in just a second. I mean, while we're waiting, I can show you guys just a few little basic things. With the interface that we have, what we have over here, starting with our dialog box, is that if you hit the little down arrow here, you will see that we have different options of loading P3D files, load surfaces, load point clouds, things like that. Let me mute Nathan because I think I hear him in the background. All right, there we go. I muted him. So hopefully we don't hear any more background noise. Load point clouds, import coordinate files. I'll show you guys import polylines from a file today. But the important thing is the down arrows. To try and streamline our interface here, we went ahead and put some of these down arrows on some of the commands, like download Google Maps and overlay images, stuff like that. Save scene files, export. So don't forget that when you're working with some of these commands, this little button will take you to some of those. Here, draw circles, draw a point, draw a polyline, simple things like that. We have those commands in here. So what I'm going to do, I know some of the names I've seen, and it may sound like I might have a cold or something like that, but just so some of you guys know, I went into cardiac arrest in January. And during that process, one of my vocal cords got paralyzed. So it's a little hard for me to talk. But when it comes to Carlson and hydrology, I'm one of the best teachers. So bear with me. I'm hoping that eventually my voice will come back to 100%. But it's a little rough right now. So hopefully we've got most people here, and I'm just going to go ahead and get started. The first thing that I want to show you guys is talking about some of our textures and how they play into the stormwater models. If you look here, I've got, I'm going to just hit the little arrow next to textures to expand it. And under here, I have certain textures that represent different forms of ground cover. Okay, so suburban here, in this case, I'm going to define this as Kentucky Transportation Cabinet rational method. I'm going to open this up and I'm going to select suburban. If you notice over here on the side that the suburban texture has a runoff coefficient of 0.33, or if we're doing the SCS method, a 33. Okay, this becomes kind of important in the ground covers. So I'm going to go ahead and click OK, and we're going to go through each of these, and it says undefined. So I just want to make sure I define them. I'll go back to Kentucky Transportation Cabinet, scroll down, and this will be asphalt. Okay, so I'm going to select asphalt. The concrete here, if you're not sure what each of these represent, you can also turn on polylines. Well, if you notice in here, I'll get a polyline around the border here. So I'll click this, come in here, and we'll define it. Kentucky Transportation Cabinet, scroll down to concrete. Here's our curve number or the coefficient. Okay, these are customizable by you guys. So depending on where you work, you can set up your own. Here, since the headquarters for Carlson's in Kentucky, I'm just using them. I live in North Carolina, so I'd want to set North Carolina's up as my own. Again, I'll come down through here, define. I'm looking for sandy soils 2 to 7%. That's my shoulders behind the curb. And I'd come down through here, 2 to 7% lawn sandy soil. There's the coefficient, the curve number for it. And I'll leave it at that. Again, I got one last one to do. This is my toe slope. This is like grades above 7%. This is like 3 to 1, 2 to 1, stuff like that. So I'd come in here, specify this. Again, come down to the transportation cabinet. So lawn sandy soils, steep, over 7%. And I'd define that. So what I've done here is basically assign ground covers to asphalt, concrete, shoulders, and my toe slope. Okay, which we could now start to use this. Other things that we could do in here would be, I told you guys a few minutes ago that I might import polylines. Okay, so if I were to come here, import polylines from a file. Now, this comes straight from my CAD file. And what I want to bring in here are lot lines, footprints for buildings, driveways, things like that. So I'm going to import polylines from a CAD file, choose the PLN file, which is civil demo, lot lines, other things like that. Click open and click OK. I want to bring it in US survey feed because that's what I'm working in. Click OK. So just by simply writing out a polyline file from CAD, okay, this is straight from CAD, I can start to see my driveways, building footprints, and lot lines if I want to. And I can start to look at this as part of my model as well. Okay, so let's come into my buildings here. And what I could do is go to materials, come down to the transportation cabinet. Again, here I'm going to come down, let's just say roofs. So now what I could do is start dragging and dropping roofs out here to apply the roof texture, which might be a 0.98, or a coefficient or a curve number of 98. And then you just simply drag and drop these onto your site, And now you got to do each one, but the nice part is the polylines will limit. Also, if you wanted to start doing your driveways, because that could either be concrete or something else. In this case, I'm just going to use the one that is set up out from the Kentucky Transportation Manual as driveways and sidewalks. Drag it out here, pop it on there. So again, when you start to do these, they become part of the model. You understand? So that's really cool when you start looking at some of these things from an overall standpoint of your watersheds and the weighted C or weighted coefficient that you'll be using when you start to calculate your watershed areas. I could leave these in here and just kind of go on, but I'd really want to start plugging them all in. But for the safety sake of time and showing you guys different parts of the demo, I'm just going to take them out right now. So if I highlight these, I can right click and just simply delete them. So once I start to delete them, you know, I've got my textures in here that I could probably go ahead and delete these as well. And you see how they just start to go away. And we're left with just what we started with. But it's real simple to start adding in different coefficients and ground covers based on the jurisdiction requirements. And for the transportation cabinets, this is theirs. Okay? So now, let's start talking about inputting in storm drainage systems. Okay? So what I'm going to do is I'll minimize my textures. We'll come up here, and over here, if you start to notice, from the rain cloud over are a lot of the hydrology menus. Okay? If you're looking for settings in hydrology, you can come up hydro, come down to hydro settings, and here you can start to specify specific pipe size libraries, inlet libraries, the structure, sewer, culverts, sewer structure libraries. This would be like what's below ground. A lot of these come straight from the Office software. So if you're familiar with the Office software, these things you've probably already created. You know, the pipe mannings in the roughness coefficients, things like that. Your maximum time of concentration, you can specify that here. Add watersheds to all surfaces. There's certain things you can do, check, and to use. Now, if you wanted, like for me in North Carolina, I typically space my inlets 5 feet off the PCs and PTs of your intersection radiuses. So I have that specified here. I don't want those, what would you say, the straight line catch basin models in my returns. So I specify this. Also, if you go to your sewer network settings, you can specify what your starting inlet. In this case, it's curb inlet 1 for me. And the pipe name, you'll see these pop in just a second. Elevation rounding factor. I don't like having a, let's say, a 0.67, 100.67. Round that thing up for me to make it easier on the surveyor guys who are going to stake this in the field for you. So I round mine. So I like to do that. Automatically set all inverts. Yeah, let's do that while we're at it. Set pipe sizes, that's fine. Do my step up. And if I want to minimize excavation. Now, one thing that I do here in North Carolina is that on sanitary sewer, I'm allowed 2.4 feet of free drop inside a manhole. I don't differentiate that between storm and sanitary. So I'll just go with that 2.4 feet. I can adjust it later, but for me, for the time being, let's roll with that. Minimize pipe size in design. That's kind of like a no-brainer. Makes me laugh. So if you guys have ever heard me teach hydrology, you'll hear me make fun of this command. But it's something that we want to do. The Htl computation method. In this case, we're going to use the Federal Highway. We have Virginia DOT or VDOT. We also have something set up in here for Ohio. Now, if you have specific requirements by the jurisdiction, if you let us know, we can add some of these in here for you. But typically, federal highway works for everybody. Your friction slope averaging method, I've got mine set to arithmetic. We have conveyance and geometric. The minimum time of concentration. A lot of times you'll get this requirement that 5 minutes for storm drainage design is the minimum. It may end up being 7 minutes. It could end up being 3 minutes, but this is kind of like just in my opinion, this is a safety measure. Okay, if you always assume 5 minutes, then it's kind of like all the water that comes from the sky makes it to that inlet in 5 minutes, no matter what. Okay, it could take 7, it could take 10, but that's what this is kind of dictating. And your maximum gutter spread, which I'm going to show you guys how that plays in. In mine, it's usually in North Carolina, half the travel lane or 8 feet, okay, which is what Jeff just got going on here. This disabled by our capture all inlet flow bypass disabled. That is assuming that every drop of rain that falls from the sky is going to go in that inlet. We know that don't happen, but again, we can assume it. So we're sizing pipes, basically saying every drop of rain is coming in the inlet. That's what this does. To me, this is another safety factor when you're sizing pipes. Also down here, we can dictate what the pipe at junction match. We want to match grounds, inverts. What's our main design criteria? Cover or slope. In my case, I'm going with cover. And check the minimum cover at structures or along pipes. My minimum cover is set to 2 feet. My maximum cover is set to 10 feet. I'm going to be notified by the program. Okay. My minimum velocity, for me, typically, it's 2.5 feet per second, making sure you're keeping the pipes clean of debris, leaves, whatever. The maximum velocity, I usually will set this to 10 feet so that I'm told if I've got velocities of over 10 feet per second, especially at an outlet pipe where you're probably going to size riprap, that type of stuff. My minimum slope, my maximum slope, and just a normal slope. If I switch to slope becoming my main design criteria, see how this ungrays? But I usually use cover, and that will dictate. Now, we also in here have the ability to set up some ditch parameters, whether or not we want to use a V channel that kind of follow the surface model, a trapezoidal channel, where in this case we have a 5-foot flat bottom and 2-to-1 slopes, on our toes. We've got some of that stuff in here. We also have lining material for our ditches. Nathan will talk about this a little more coming up, but we can also specify some shear stress and what channel lining to use. And based on the order of these, the program will go through and say, well, can I get away with grass lining? Or do I need reinforced matting? Am I going to need riprap? And it'll go down through here and pick the one that you need based on the topography and your channel. So it does some of that stuff for you as well. But now, going through some of that stuff kind of fast, I want to show you guys, and also leave Nathan time to show you some of the culverts. I'm going to switch over to pipe properties here. Nathan's going to show you some of our models, okay? But I'm going to show you the network, okay? So this button here starts us out at our network command. So once I click this, you can see that my scenario back here kind of grays out. If I wanted to go to a wireframe, I can click on the wireframe. It just depends on what you like, okay? I'm going to turn the wireframe off. I want to make sure that the structure that I'm working with is my North Carolina combo 5x5 inlet, okay? So I'll select that first. It tells me that this is a combo on grade inlet condition, and the structure below ground is 5 foot by 5 foot. Now, one of the cool things that they've got in here is a gutter snap, but also when I'm adding inlets in, I can snap to a low point. So if you look, when I zoom in here, I get a circle. That's the low point snap in this sack, okay? If I move out here, you're seeing the gutter snap. But as I slide around, see how nice that is? That's the low point that I'm going to place this inlet. You know, so it's simply just pick. There's CI1. Now, I'm going to zoom out here just so you guys can see kind of how easy this is. As I'm moving along this curb and gutter, there's a low point. You see the contours are pointing to it. There it is right there. So no matter how far out I am, I'm snapping to the low point in the gutter right there. There's pipe numbers, inlet number 2, and there's my minimum pipe slope. Again, come down through here. Boom, there's a low point. Straight across the street's another one. Boom, pick it. You see, now what's happening, if you look at this pipe slope, it's at minus 2% because this pipe is cover dictated down here at the low point with me. So what I could do is come down here and just pop one. You remember how the houses looked. I knew I had a low point down here or an outlet point that I'm going to place. Pick, boom, there's CI5 running at 0.5%. Now I can simply come over here, change. What I need to do is, because this is no longer an inlet, I'm going to outlet to my detention pond over here. I'll change my inlet and we'll come down to a North Carolina head wall, come over here and just pop that guy in. So now you see that basically I've created a pipe network here that's showing you. Now is when the wireframe comes in just a touch more handy because we're looking underground at the pipes. See the pipes? And everything is being shown here. Nothing's been designed. It's just running at my minimum slopes and cover. Okay, if you look here, I do have a 10-year storm that I've already set up for my pipe event or my storm event. And if we go up here and we start to look at this, you can see that I'm looking to solve for peak flow. We also have volume transfer in here. What hydro method am I using for my time of concentration? There's the hydro method, the TR55, the chromatic wave, and a TR55 and chromatic wave combo. That would be like your sheet, shallow, and concentrated channel flow type of calcs. In this case, I'm just using the hydro method. We've also got, you can slide this over so I can show you. Here's my storm event. So basically, no matter where you're at, if you are tied to your state plane coordinate system, you can come right here, click this button. We'll go out and ping the NOAA Atlas 14 maps for you and download those numbers for you automatically. Okay, now some jurisdictions have their own, and you've got to go in there and set those up. You can still do that here. You're not restricted, but it sure is convenient to click that button, and because we're tied to grid, we get the rainfall data. So, to me, in North Carolina, as long as I can justify where my stuff comes from, whether it's Diener, NOAA, the city of Raleigh, whoever, I can justify they give me those options. So we've got that here for you. Now, what rational method? We even have that going on as well. So we've got modified, the DeKalb, and universal rational. So I'm going to use universal rational. What's storm? Well, here's all the data that I downloaded. I can run any of these storm events. For pipe sizes, I'm going to do the 10-year. So let's set it. We've got our ponding, things like that. We can show you low points. We can show you gates, or we can, and Nathan will show you some of that shortly. We can show our runoff polylines if we want to see those. But for right now, we'll just leave as is. I'm going to click back up here into my surface model, take it off wireframe for the time being. Highlight my pipe network, and I'm going to click over here, and I want to show you guys the edit sewer network. If I click this, this shows me a profile of the pipes that have been that I just laid out. Okay, there's no drainage areas calculated for yet. The sizes are all 15. Okay, the runoff coefficients are all set to 0.5. No time of concentration. None of that stuff is set in here. I just want you to see it. Now what I'm going to do is I'm going to come in here, select the pipe network, right click, and design it. Now we're going to look at flows. Now we're going to look at time of concentration. Now we're going to look at the HGL, the EGL, and size these things for you. Okay, so if I hit the design button, what it's going to do, if you look down here, it says the pipe network editor. It's running the model and the storm event for us. Okay, it's done, and now you can start to see the different drainage areas for each event. Okay, you guys see all that? Let's look at the profile again. Come here, right click, edit the storm network. Now you see the hydraulics that are in here. You see the flows, you see the weighted seas, the drainage areas coming to each inlet, time of concentration. Now, if we use the 5-minute, we could, but these are the real ones. If it was the minimum, it would be 5 minutes. Okay. Mainings in for the roughness of the pipes. You see the pipes went 15, 18, 18, 18. They're not all 15-inch anymore. To handle the pipes not being under pressure. If you don't like it, change it. If you don't want RCP3, change it. Change it to whatever you want. RCP3 is mine. You don't want round, change it to rectangular if you want to. But you need them in your library. So you guys see how all that works. Now, you remember how I told you I couldn't stand stuff not rounded. My stuff is rounded. Now, if I want to come in here and put drops in these, I can manually do it right here, you know, which is a lot of how I design. You know, I do a lot of my designs this way. Get me in the ballpark, and then I'll come in here. Maybe I want 2/10 drop in here. Maybe I want a 10th drop. I can come in here, start modifying these. Double click. That's 833.8. Maybe I want to do 833 point something else, you know, or change it here. You can, you know, it's all customizable by you. If you want to change these settings, you can. If you start having multiple runs of pipe, you can. It's also pretty easy to come in here and start looking at gutter spread. If you see a red line, that means I exceeded 8 feet of gutter spread. I've got to do something, okay? If you come down here and look, I think my gutter spread is okay, but I don't think it's right with this storm event, to be quite honest with you, right off the top of my head. I don't think this is right either. Typically, you will see gutter spreads that are just ponded out here, where you just see a little ellipse out here. It could have been something I did. I don't know right off the top of my head what it is. I also know that if I wanted to come in here, let's just turn this guy off. If I want to come in here and start adding inlets in, I can just pick here, highlight the pipe, make sure you have what you want to put in here, highlight the pipe, and pick. You see what happened? I just added in another structure. I can move this structure anywhere I want to if I finish the command. Now I can pick this structure and move it, start to move it around. Maybe I'll pick it right. I might not do it because my surface is not on. Could be. And so you guys can see kind of what happened when I go getting wild and start placing inlets in places that I'm not quite ready for. But in a nutshell, that's kind of what I wanted to show you guys. I hope Nathan's here. I muted him. Let's see if he can talk. Let me unmute him right quick. Nathan, are you with us?
Yes. Let me fire up P3D, and I'll take everybody through a quick watershed and culverts demonstration.
And he'll show you some different stuff, but really what I wanted to show you guys was it can be kind of easy to go popping in inlets and, you know, where the low points are. And, you know, of course, for most examples, I'm going to have one here, because I don't want water passing through my intersection, you know, and doing things like that. But just to show you guys real quick how to pop in some boxes and an outlet. Another thing before I let Nathan have it is I would like for you guys to also see that we can start reporting the networks once we've built them. You know, so if I click on report sewer network and just do them all, I can come in here and report structures, come to my pre-set up. These are set up for the transportation cabinet. The
bottom one.
Oh yeah, thank you, Nathan. Grab that bottom one, open, just do my test one, override it, and you can see our custom reports in a PDF form for you. You know, tells you all kinds of stuff about the 5x5 catch basin underground.
And these PDF reports are completely customizable, so we can put your logo, letterhead, other content that you need to have on the different pages, and then we just have special codes where you insert the actual values and where you want them to show up in the diagrams and so forth.
I'll show you right quick the hydraulic grade line calculations. Again, customizable, whatever you want. But you can see stuff in here for the hydraulic grade line. I'm not going to save it. Again, also, if you want to take this stuff back into CAD, which a lot of times I do, I will come in here. This is my personal one that I use, that I place on my plans somewhere. I'm just going to show you display, and you can see here's all the stuff that typically goes on my plans somewhere. And I would screen print and plop them in my CAD file. You know, that's what this one does. And the last thing before I turn it over to Nathan is, you guys see down here, I got a pond. We can report the pond stage storage at this point by click on my pond, expand this, and pond stage storage. So what this thing's going to do is go through and do my stage storage for this detention pond. If I want my PDF report, again, I can, where's my go to do? I got to run down through stage storage to test. Yes. Now, once we start putting outlets and structures to drain this pond, you would start to see things like that, which is coming. But here's your storage curve, and here's your volumes of that pond in acre feet, cubic feet, whatever you want it in, you know. And then again, the PDF. Nope, I'm not going to save it. And you got to create, if any of you guys who use the Office software know that you need a capacity file. That's what this is going to generate, you know. So you can do those things in the Office software as well. So
Hey,
anyway,
Mark, can you export this as a SU file and show them how to create that CAD deliverable with the plan and profile sheets? Because I think that's real important to show the complete round trip.
So once you've kind of you've designed your pipes, you can export this. And any of you guys who know the SCW file, the SU file, is what this will create for us. And I am just going to make this, we'll just call this, make sure I know where it's at, the Carlson data. I'll put it right under my P3D, and we'll call it test. .scw. Save. Okay, so now what I could do is come back in here, minimize, run CAD. Okay, we'll let CAD open up right quick. Now, I'm not going to guarantee what you get here because this is my first run and I'm working in DWG #1. I will come in here and do my plan view label settings. Plan view label settings will set specific, and I'm going to set this to my storm final. This is how I want my pipes to look when I bring them in. Okay. I'm going to set OK. I'm going to set this sewer network here to be that file I just existing. Let me browse here. Show you the one that I just created in the Carlson data P3D. There's that test. Okay. There's my pipe run. Okay. Open. Okay. No, red's telling me I don't have a rainfall. That's fine. And say, okay, is it gonna make me set that thing? Shoot. That's all right. Hold on. We'll set it. I'm gonna set it to Wake County. So that's Wake County, North Carolina. We come back in here, draw sewer network, plan view, and let's zoom. Extents. There's my pipe network back in CAD that I just created, the way I want my pipes to look. the arrows, the number labeled, and so on. Had I went back in here and set my plain view label settings, which is it, I don't know why I went to specific, or went back, but I went to Storm Design, okay, network, draw sewer network, plain view. Now you see, this is like as-built for me. I don't show the towns and municipality this unless they ask. Most of the time you get an arrow and you get a number and you'll see a pipe chart. But if you want it, there it is back in CAD. So, you see? Now, very soon, this is going to be done dynamically when you minimize CAD and you work in P3D. Oops, sorry about that. And you work in P3D. When you minimize this, you'll see this without having to do what I just did when I opened CAD. Really super cool stuff coming, you know. But anyway, Nathan will probably show you that in a second. So, Nathan, if you're ready, I'll let you rock and roll.
Okay, so let me share my screen.
Let me make you presenter. Yeah, you may already be. If you guys can see Nathan's screen and not my CAD screen, raise your hand for me real fast. If you see Nathan's screen, it should be P3D, have a gray background. Thanks, Dan. You're good, Nathan.
Okay. So I'm going to go through a very quick watershed and culvert demonstration. So the first thing I'm going to do is come in here and I've already got this set up. So P3D remembers the last storm settings that you had. So basically, we're going to use compound culvert discharge, which is different than additive discharges. This is the more commonly accepted way, especially for DOT work. Going to use kinematic wave sheet flow, and then we're going to automatically calculate these lengths. I could also use fixed lengths down here. There's a lot of settings for your storm settings, and then for the channel liners, I'm going to use a fixed number of channel segments. We have a bunch of options here to determine channel segments, but I'm just going to set that at 3. I've already downloaded the NOAA rainfall library because I have my projection set, and I'm working in Kentucky North U.S. Survey State Plane Coordinate System. So you can see I'm tracking, and my lat long is 38, 38, 38. And what I'm going to do here is, and I've already got all my textures mapped to the different runoff coefficients that I need. In this case, a lot of them default to 0.65 for rational, 65 for the SCS method. I'm just going to calculate the storm. I'm going to show you how to control the watershed boundaries a little bit. We have a couple of different tools for doing that. So we'll give you a good first pass on this calculation for you. But then after that, we have some really simple tools that allow you to modify these areas. And so the first thing that I'm noticing is that I've got 2 different ponds here. So I definitely have water buildup where I'm going to want to put culverts. I can see that there's water ponding up in these 2 roadside ditches, but they all happen to be in the same subbasins. And culvert calculations need to go across subbasins. So what I'm going to do is I'm going to use our simple red gate technology. And what that means is these blue gates, these are adjoining subbasins logically. And what I'm going to do is I'm just going to double click on them, and I'm going to turn them red. And what red does is red forces the water not to flow in there. So you basically you can toggle them from a distance, but when you see that gate show up, that means they're red gated, meaning we're cutting off the water. We're going to isolate those sections. I'm going to do that one. I'm also going to isolate this one as well. And so I've modified those. Now what I'm going to do is recalculate the storm. And what you'll notice is that I have more subbasins that are going to be created, and it's going to isolate those pockets that of ponding to smaller sub areas. And so now you can see we've got a separate subbasin here. We've got a separate subbasin here. And if we come down into this roadside area, you notice that we've got a separate small sub-catchment basin here and one here. Now, one thing that we can all see, since this is a downhill and a super, we're in a little super elevation situation here, coming along a spiral. And I would prefer this boundary to be straight, but there's two boundaries, right? There's this subbasin out here, which is subcatchment basin 4. So if you look at my tooltips, as I move my mouse into a subbasin, we give you all the information for that basin. So that's 6 and that's 4. So they have a common adjoining edge here. But what I want to do is modify this edge. We have a nice tool that's called Multiple Edge Editor. So what I'm going to do is turn that on. I'm going to turn on my vertex snap, and I'm just going to pick here and here, and the command is over. And what that just did was that modified both subbasin 6 and 4 at the same time. And it's also turned it orange. And so now it's become a watershed control boundary. And what that means is that it's been user modified. So if I recalculate my storm at any point, or if I add another storm type, because we can have 1 to n storm types here. So we can have a 10, we can also have a 50 by simply just adding. We can add more storm events. If you want to analyze based on different events and then create different reports for that for comparison. So in this is a very easy way to go and modify and control your boundaries. So one is the red gate technology. The other is just simply modifying these boundaries. We have some additional tools that will allow you to combine two catchment areas. So if I wanted to combine these into one, I can simply just, or if I want to combine this little one here, this little sliver to this one, what I could do is I could use our combine and split command. And so basically I'm just going to pick inside of this one, and then I'm going to pick inside of that one, and I just merge them together. And notice it turned orange because it's been user modified. This is not what the program automatically calculated. I can also split a subbasin, so I can draw a polyline down here, and I can use the same command. I can pick inside of here, and then also pick the polyline, and it will split it in two. So a lot of different tools there. And if you don't like the shape of this, again, simply use the tool here to make any cleanups, that you think are appropriate in here. If you want to, kind of smooth this out a little bit more. So very easy to use tools in doing that. And then, like I said, if we recalculate, we'll maintain all of these orange control boundaries, which is what these have become. We have another tool that will allow you to draw a polygon in the scene, and then you can create an inclusion boundary. So the way that works is essentially if you have a really large surface, but there's only a small area that you want to consider, you could simply draw a polygon around there. And one of the commands is to create a new watershed boundary from the polyline. And so I'm going to click on that, and I'm going to come over to the command window, and I'm going to tell it it's going to be an inclusion boundary, which means include everything inside of it for watersheds. And I'm going to hit finish command. And now it's added another watershed inclusion boundary here to my list. So now what is the effect of that? So I'm going to calculate my storm. Notice that it's maintaining the user controlled boundaries. But what it's done is it's now constrained the analysis to entirely inside of this inclusion boundary. And so essentially now I can get on with doing my culvert design. And the culvert design is as easy as this. So I have my low points. I can see the low points here. And so what I'm going to do is I'm going to click on the draw culvert command. I'm going to click from that low point, and have it drop out into this ditch. And we got an automated 6 inches based on the flow. So we're actually sizing the pipe as we lay this out. And I'm going to click on this guy, make him as shallow as possible, and -3. That's good. And one other thing that I want to show you is that in this subbasin 9, right, which is the basin that's actually catching the water, you'll notice that we have these cumulative rain intensities and cumulative inflows. And so what's happening is that this is the peak flow that's calculated just for the subbasin, but the influence of having these two culvert pipes connected across here have added this cumulative flow and modified the rain flow. And you'll notice that we're at 14.764, but what I'm going to do is drop a culvert from this pond down into this nice little natural channel at a -2%. And you're going to see the headwater. So basically what you're seeing now in this pond, this magenta line represents the maximum topological bowl, as much water as this thing can hold without spilling over. During the peak of this particular 10-year storm, the blue outline is the maximum depth that this pond will reach during the storm without the culvert pipe. With the culvert pipe placed, this yellow headwater represents the maximum depth that the water will rise up to if we use this particular size culvert pipe, which is 3, and it's an 18-inch pipe. So we can modify it. We can put in additional barrels, and as we do, you notice that the headwater changes. So any changes that we make here, so if we change this from concrete down to RCP3, that didn't have much of a difference. The calculation mode, we have it as optimum, but a very common and new method that P3D fully supports in both calculation methods and in reporting is the new HY8 methodology. So when we calculate this HY8, we typically get slightly smaller pipe sizes in there. We can also override, instead of calculating the pipe size, we can say we want to calculate the headwater. And so if I want to come down and say, instead of an 18-inch pipe, I want to put in a 24, which is going to reduce the headwater, right? So this would be the headwater for a 24-inch pipe during this 10-year storm. So and again, we're automatically calculating that for you. And if we come back down into this subbasin 9, remember it's catching all the water from all these culverts so far. And you'll notice that we're up to a cumulative flow of now 31.7 CFS. And the other thing I can do is quickly drop in another culvert from across the road. Make sure that the pipe slope goes green, which is negative. So as I'm drawing it, I can see where it drops to green, and I'll just select that. And we get an automated headwater calculation, and we get a 21-inch pipe in that particular. And now if we look at the sub area, we're up to 62 cubic feet per second coming into here from all of these different areas. And just to show you the HY8 reporting that we have, I'm going to go to this pipe 3 and click on the PDF report. And I'm going to go to the HY8 report. I'm going to call it test. So basically, this is a nice, fully detailed HY8 report. So crossings at the roadways, your ratings curve, the summary table, and the performance curve as well. Downstream channel ratings. So we also deal with downstream channel information as well. So for every one of these culvert pipes, we have a tailwater condition down here at the bottom. So you can change that tailwater condition and slope. So we're reading the slope automatically from the scene. But you can change the shape to a surface sampled. So we'll actually sample the ground and for this 10 foot wide to do the downstream. Or you can use a fixed shape ditch. And then if you modify that, you notice we just got a different outlet flow depth because I changed it to surface sampled. So a lot of powerful and yet easy to use tools in here for controlling your watershed boundaries, for automatically calculating them, and then to be able to modify and isolate them. We do have another nifty little tool that allow us to even place another pipe. So I'm going to show you another way that you can control. So that's -10. We don't need to be quite so deep. We'll just do -3 across the road. And it's really huge because it's picking up all of the CFS from this area. But if you turn on this create sub area at inlet and turn that on, what that does is that will force a sync point here, and it will only look from here and up as to what is actually contributing to it. So if I recalculate the storm at this point, this is yet another way that you can control watershed boundaries, because culverts by definition need to take water in from one subbasin and then exit water in another one. And so what you're going to see here is that not only did the pipe get smaller, but now we have a new sub area. So from this point, this is the subbasin that will contribute water to that point. And we can also see that it's reduced the amount of water that's going to come over into this pipe, where I think before we had a 21-inch pipe, but the headwater was much higher. Now we're down to an 18, and we still have a nice, decent headwater value here. So again, all of this was automatically taken care of and computed at this point, in which we can save all of this information back to CAD, plot the ponding, we can label it, we can bring all the culverts back in, all the head walls, and so forth for complete CAD documentation. And then again, we have lots and lots of reporting built in here for both the ponds and also the storm events. So we have a rather extensive library of reporting capabilities at this point in the new Hydro 2018. And that is watershed control and a quick overview on designing culverts.